Students, today we'll start with what is junction field effect transistor, that is JFET. So junction field effect transistor, JFET, which is the first type of FET, because in that we have studied mainly two types. So JFET and MOSFET. So first we will take what is JFET. Now in this also you will be having two types. One is N-channel JFET, and one is P-channel JFET. P-channel JFET. Now the construction of both we will see first. Now in that, if you speak about N-channel JFET, you have to first take a bar, semiconductor bar of N type of semiconductor. This is N type of semiconductor. So this is a bar which is N type of semiconductor for N channel. Okay. Now in this bar you have to induce P type of semiconductor on both these sides. So here you will be having P type of semiconductor, and here you will be having little P type of semiconductor. Now both these P type of semiconductor are internally connected. These are internally connected. This is connected to this internally. So they both are internally connected. Okay. Then you can take one terminal here and you can take one terminal here. So now there are three terminals what we are showing. One is here, which is connected to both P-type terminals, and one is on the bar on either side. One is here and one is here. So the down part, we will name it as source. We will name it as source. And similarly, the same type of connection what we have on the top, we will name it as drain. Drain D. And the terminal which is going to connect the P type of semiconductors will be named as gate. So JFET now is a three-terminal device. It is having source, drain and gate. Source and drain are for the main bar, and for the opposite type of semiconductor which are internally connected, you have a gate terminal. Okay. Now in this, because FET was basically called as unipolar device, in this the flow of current will be only because of electrons. So this is an N-type semiconductor, and in this electrons are going to flow. Electrons are going to flow. Electrons has to flow from source to drain. Source to drain. Electrons are going to flow from source to drain. This is the flow of current for this device, N-channel JFET. Now this flow from source to drain will take place only when you apply a proper voltage for source and drain, so that electrons from here will repel and electrons here will be attracted. That supply you can give. Now you can give one more supply here between gate and source. Now that supply will be very important, because gate is going to act as a control terminal, and that supply should be reverse bias. Should be reverse bias, because originally when you make this arrangement, this is P-type material, this is N-type material. So you have a normal PN junction here. You have a normal PN junction here, and you have a normal PN junction here. PN junction here. Okay. And between these two PN junctions, you are having this path in which the majority charge carriers of that particular bar, in this case it is N-type, so electrons, majority charge carriers, will flow through this path, and this path will be called as channel. This path will be called as channel. So this is a channel. Okay. Now you are going to apply here a voltage which will reverse bias the PN junction on both sides. Now if you increase this voltage, if you increase the reverse bias voltage, this depletion region will increase. This depletion region will increase. So here you have increased the depletion region. So here you have increased the depletion region, making the channel narrow. This has become narrow. So resistance is high. Resistance is high. Current is less. Current is less. Because flow of electrons will be made less because the channel width will decrease because you have increased the reverse bias. Similarly, if you decrease this reverse bias, again that width will open up and more electrons can flow. That means the flow of electrons from source to drain, which is constituted as flow of current from source to drain, will be controlled by the reverse bias voltage applied to the gate. If the reverse bias voltage applied to the gate is less, then the width is more electrons will flow, more current is flowing from source to drain, which is called as drain current. If the reverse bias voltage is increased, depletion layer will increase, channel width will decrease, and when channel width decreases, less electrons will pass, so current flowing from source to drain will be less. This is how you are going to control the current flow, the output current, by the input voltage, by the voltage. So it is called as junction field effect transistor. The junction field effect transistor. Junctions are going to affect the flow of current. So it is junction field effect transistor. So here the gate terminal is the control terminal to which you are going to apply a reverse bias voltage, and that will control the width of the channel from source to drain, and because of that current from source to drain can vary either more or less. So this was in your N channel JFET. The same thing you can see in P channel JFET. In P channel JFET, what will happen is you will be having a P-type semiconductor bar, and in that N-type semiconductor will be induced. So this will be called your source, this will be called your drain, this will be called your gate, and both these gates are internally connected. Similarly, here you are forming a PN junction, and here you are forming a PN junction. Okay. Now here, because you are using P-type bar, the flow of majority charge carriers is holes. Holes are going to form the flow of charge carriers from source to drain after you apply an appropriate voltage. And same thing what you have seen here, same thing you can do there. If you apply a reverse bias voltage here, this width can increase. If you increase this voltage, the width can increase, and the flow of holes, which is called as channel, the channel width will decrease. And once the channel width decreases, less number of holes will flow, so less number of current is flowing from source to drain. So same concept what we saw in N channel, same concept we will see in P channel only the semiconductor names will be reversed. So here it is a N bar with P type of gate, here it is P bar with N type of gate. Otherwise the operation is same, otherwise the logic of operation is same. The same type you are going to control the gate voltage and you are going to control the current from source to drain. So in N type JFET, the electrons are making the flow of current, and in P type JFET, holes are making the flow of current. That is the difference between them.